Hey guys, can somebody confirm if my voice is audible or not? Hey. Hello everyone, this is Satyajit Pattnaik and welcome to my channel. In case you are new to this channel, please subscribe the channel and hit the bell icon to get notified on my future videos and sessions. Today we have with us Usha Rengaraju. She is working as a principal data scientist at one of the organizations and she's also India's first female Kaggle Grandmaster. She's also a part of our various data science communities where she helps other fellow members and data science enthusiasts. As most of you already know, I have recently started doing such live workshops and webinars. So today's topic is going to be very fascinating. As you can already see, the topic in the screen itself. Today's topic, Usha is going to give us a walkthrough on one of the use cases in deep learning for computer vision. The use case is nothing but cancer prediction use case. So let's get quickly started on this. In case you have any questions in the middle of the session, you can post it as a comment or in the live chat, and I and Usha will try to get back to you with the answers. If your questions are somehow missed, you can definitely reach out to me or Usha directly, preferably me, uh, as Usha might be busy with other activities too, right? So you can just get back to me. So let's get started, guys. Usha, you there?
Yeah, I'm there. Yeah.
Yeah,
Can I
Usha, you
share
can
my screen?
you can take it right from here. Yes, thank you, Usha.
Yeah. Hope my screen is visible. Is my screen
Yeah,
visible?
visible. Yes, visible.
Yeah. I'm going to share a few links. Kindly share it with the audience. So this is the notebook.
Sure.
I'll just put it in the comment. I mean, I won't be able to post it directly. So okay, I'll just share it here. Kindly post it. So this is the collab notebook, and
Okay. So just a moment, guys. I will
this
just
is the
update.
competition page, and this is the
Okay, just to interrupt, I have already provided the links in the description itself. But yeah, in case you just want to go through this video, then you can run your collab files, and also it's okay. Okay.
yeah. So the use case today is identifying melanoma lesions in images. And this is, was a Kaggle competition. I've shared the link with Satyajit. He might have put this link there. Please open the competition link. So if you check, this is a competition which was launched last year, and this competition was organized by two research organizations, yes, IIM and ISIC, and these are a couple of research organizations who are working to bring down the mortality in skin cancer. If you take ISIC, this is a second organization. This organization has got a lot of collaboration with academia and industry partnership, and they maintain the huge public repository for a lot of images.
Usha, just to interrupt you, sorry, for a second. Your voice is little bit not clear properly. Can you just join once again, if possible?
Yeah, sure. I'll join once again. Yeah, I'm
Yeah. Sorry, guys. Let's give her 2 minutes. She will join. In case you have any questions related to CNN or some image classification problems, be it on CNN 1D, 2D, 3D, anything you have, you just type in the chat box. In the meanwhile, I will try to answer them. Okay, she has joined.
Yeah, I joined now. Is my voice audible?
It's better. Yeah,
Yeah. I'll share my screen.
sure.
Yeah. Now, hope my voice is audible. So this is a Kaggle competition which was launched last year, and this had two research organizations coming together to launch this competition. If you see ISIC, it is International Skin Imaging Collaboration, and this particular organization has got a lot of academia and industry partnerships, and they have a huge publicly available repository for archive for image data sets, particularly the for specific to skin cancer imaging. And a lot of researchers can make use of this particular archive data set to, to do research in skin cancer, which will bring down the mortality in skin cancer. And so this is the aim of ISIC. And yes, IIM stands for Society for Imaging Informatics and Medicine. This is also a research organization. They are interested also to bring down the mortality in skin cancer. And so both these organizations have got the similar aims. They came together to organize this Kaggle competition. And if you take this Kaggle competition, if you take the whole problem statement revolves around skin cancer, specifically a type of skin cancer called melanoma. So, in skin cancer types, if you say melanoma is not that frequently occurring types, but if it occurs, there's a high probability the patient might die. So, a small statistics in 2020 alone, there were 100,000 people who were estimated to have melanoma in United States alone, and out of which there were potential, 7,000 deaths, which was predicted to have occurred. And this is the statistics about skin cancer and melanoma. So melanoma is just in US, if it's 100,000 people, then that's a huge number. It's definitely worth studying more in detail. And this is about skin cancer classification. And you will also see the problem statement revolves around skin cancer's classification, particularly a type of skin cancer called melanoma. And the whole problem statement here is just this diagram speaks for itself. I've got images with melanoma on my left, and I have images without melanoma on my right. So I have to make a classification if this particular image has got melanoma or not. So this is the whole problem statement. And so I'll head on to the competition page. If you see the competition page, you'll have a data section, and when you click on the data section, you will have the data in the form of JPEG. You have test and train neatly split. You can either use it as JPEG, or you can also use it as the test format. If you want, you can use the files also. So you can either use it as a JPEG, it's in JPEG format. If you want, you can use the JPEG format, or if you want the DICOM format, you can still go there, or it is also available in the form of TF records. And you can also use the TF records. So you can use one of these formats. And see, if you see, IAM, see, DICOM is DCM, this format is DICOM. And see, this whole pipeline is going to be taught in TensorFlow 2.0. So I'm going to use everything related to Google. So the TensorFlow records comes from the TensorFlow ecosystem, which is part of the Google. And so I'm going to use the TensorFlow records here. And but you can choose to use any of the data formats. All of it, has also, it doesn't make a difference which format you use, and you can make use of anything which you are comfortable with. I'm going to take TensorFlow records because the entire code demonstration is going to be in TensorFlow 2.0. And so this is about the data. And now I have my overview here. You can go check the evaluation. It's area under the curve. And you have, this is the problem statement and the competition page. Now we have seen what is the problem statement. Let's get started with the code walkthrough. how to deal with this problem. We have seen quite a bit about the problem statement and the data set. And now we are very clear that you have given an image. You have to classify if it has got melanoma lesions or not. I'm going to install the libraries, and these are my import files. And then, I'm going to use something called TPUs. So, what are TPUs? Even in your collab, if you go to the runtime and change runtime type, you will find three options. One is none, GPU, and TPU. So, what are TPUs? So, TPUs are runtime accelerator. Again, it comes from the Google ecosystem, which is part of Google Cloud Platform. It's a proprietary to GCP. It's not outsourced yet, meaning you cannot go and buy a TPU pod. You will have to use GCP to use TPU pods, and you cannot get TPU pods in the other cloud ecosystem. It's only proprietary to Google. And so when you take for a you all of you are already using TPUs, in the sense, if you take a lot of Google applications like Gmail and Chrome, and a lot of these applications are already running in TPUs. So it's a Google's in-house runtime accelerator, and most of the applications coming out from Google are already using TPUs. And so when we have GPUs, why TPUs? TPUs are, if you take a benchmark data a model like ResNet 50 to train ResNet 50, when you compare the training performance of ResNet 50 with GPUs and TPUs, TPUs are 27 times faster than GPUs. And so GPUs are very, very fast, but this comes with a caveat that you should not use TPUs for something like tabular data where you may not see a bump in the performance. You have to use TPUs for something which is really involves a lot of multiplication and a lot of addition. So you have to use TPUs for the right purpose. And so this is about the TPUs. So now that we have seen we're going to use TPU accelerators, see, there's no compulsion that you have to use TPUs for this competition. I'm just using TPUs because I want to introduce you to a different kind of accelerator. That's all. So you feel free to use any accelerator which works for you. And next up, now that I've taught you what is TPUs and a little bit about TPUs, let's start coding. TPUs, in order to use TPUs, there are a few things which you need to do. First, you need to identify a remote cluster which is available for you, then initialize and connect to that cluster, and then create an object of tf distribute experimental.tpu strategy and pass that TPU object there. So this is a bunch of steps you need to do to configure your TPU. This is the code which is not going to change much. So it's just every time you initialize this TPUs in your code, you just have to copy the same code and paste it. So this is the code you need to understand in order to understand the TPU initialization. One thing here, there is an API called TF distribute. So this TF distribute is a TensorFlow core API. So the main purpose of TF distribute API is to do distributed processing. So you don't have to worry about distributed processing. Everything is taken care by TF.distribute. For instance, you have a job and you want to distribute this task into the 8 cores. You don't have to divide the task manually and distribute it among the 8 cores. That's not your job. The job will be done by this TF distribute API. So TF distribute takes care of all the distributed processing for us. And next up, you can also initially there was a requirement that anything which involves TPU, you'll have to have your data set in cloud storage, Google's cloud storage, but that's no longer a requirement, so it's not necessary. You should have it now. So you also have something called Autotune. So the reason why you have Autotune is a lot of times we may not be able to statically tune our parameters. So when you have Autotune, you can actually do dynamic tuning of parameters, and then so the next up we have the Kaggle data sets, and we are just creating a Kaggle. We are actually getting the data sets, and then we are setting the batch size. The batch size is going to be 8 star strategy.num replica sensing, that is the number of cores in your TPU, which is going to be 8. So it is the batch size is going to be 64. The image size is 1024, 1024. So far we have seen what's the problem statement, what's the data set, and then we saw about TPUs, which is the Google's in-house runtime accelerator, which is powering a lot of Google products and a lot of Alphabet companies products as well. And now let's check into what is TF records. So what is TF records? TF records is again coming. I told you, I just introduced you while walking you through the data set. The TF records is one kind of storage format, but it's not necessary you should only use TF records. You can either use DICOM or the other format, whatever format works for you. But TF records is one of the TensorFlow's own binary storage format. And the next up, you can convert any of the data structure into TF formats, like you can convert the lines of text or JSON or encoded image data or into the TF records. Next up, TF records contains a sequence of records and can only read sequentially. Each record contains a byte string and all that. So this is what TF records contains, but you don't have to know all this. What you need to understand here is TF records is TensorFlow's own binary storage format, and you can convert any of these objects into TF records. And so now that we have seen what is TF records, we don't have to sit and write code which will convert our images into TF records. It's already done for us, and we have the data available as TF records. So let's just download the data and get download the data and split the training data set into the training and the validation data set, and then print how many files are there.
Usha, you there?
Yeah, I'm there.
Yeah.
So, yeah, this is the data set. So, generally, you will have three buckets, that is the training data, the validation data, and the test data. We split it into training and validation data. So, using the validation set, you can improvise or tune your hyperparameters and the parameters of your model, and you can use test set to test your performance and the model metrics. So it is general good practice to split your data into test, train, and validation set, so that your model generalizes well to the unseen data. So this is about the data set. I'm just splitting it into three buckets. The next up we have the input pipeline. So it's again from the TensorFlow ecosystem. So everything here written in the code is TensorFlow 2.0, and all the components here are from TensorFlow, related to TensorFlow ecosystem only. So I'm going to use another API from the TensorFlow, which is TF Data API. So I'm going to use this API as my input pipeline API. So the diagram is very, very self-explanatory. From the diagram itself, you can make out. So there is, in the first diagram, if I'm going to do a lot of sequential operations, then there's going to be a lot of idle time. In the second diagram, I'm going to do a parallel processing by which I can save a lot of time, cut down on a lot of idle time. So when you do the first input output operation and the second operation map, and you don't you can go and fetch the second input while you're processing the doing the map function for the first input output you fetched. So that way you can save a lot of time on idle time. So let's look at the TensorFlow's TF data input pipeline. So there are a couple of things which you need to understand. There is a particular function in TF data pipeline which will take the data set and convert it into TF data object. And then once you convert it into a TF data object, you can apply multiple transformations on it. So that's also one of the advantages of API. So if I want to like do map, batch, shuffle, and prefetch, I can just call a function and get it done for you. And there are a lot of transformations which is possible here. And So I'm going to show you there are a lot of utility functions which I've written, and for you to understand it better, I've drawn a simple diagram. So you have the train validation and test set. Inside my train validation and test set, I'm loading the data set, and then I'm calling a bunch of methods, which is a map, repeat, shuffle, batch, and prefetch. And what happens is inside the load data set, I have a couple of methods, which is the I'm going to call a method to convert it into TF data object, and then another utility method for reading the TF records. And this is the pipeline and the call flow between the utility functions. And the diagram is very self-explanatory. So if you just see the diagram and then look at the utility functions, you will understand how which function calls which. I'm going to call the data augmentation. So if you take this is an imbalanced data set. We have, a low number of images for people having melanoma, and higher number of images for people having melanoma, low number of images without melanoma. This is a quite an imbalanced data set. So one of the conditions or one of the techniques we use to deal with imbalanced data set is called data augmentation. So data augmentation is a technique when you have a lower number of images, you can increase the number of images by doing a lot of transformations on it. So you can take this image of a butterfly where I'm going to convert this single image to multiple images by applying several transformations. I took the original image, I did the texturization, detexturization, decolorization, enhance your images, edges. This is what I can do using augmentation and increase the number of images. And then what I'm going to do is, this is about the thing data augmentation. And so, yeah, once I do my data augmentation, so if you see here, if you want to shuffle the data set, just call the shuffle method. If you want to batch a set of elements together for processing, you can call batch. If you want to prefetch a data, you can call prefetch. So you don't have to sit and manually write code. So it's a higher level API. You just have to call the responding functions to get the job done. And up next, we are going to build our model. So we are going to use something called efficient net to build our model. So far, we have seen the pre-processing. We saw about TPUs, which is our runtime accelerator. We saw how to pre-process the data. That is, we are using TF data, which as an input pipeline. And for distributed processing, we are using TF distribute. So all the input and pre-processing steps is done so far, and we have already written all the utility functions on all of it. Now the next step, the most important part, which is the modeling part. So for modeling, again, I'm going to use them. This is a simpler workshop. You can experiment later much on this notebook. So I'm going to use a pre-trained model, which is EfficientNet. So EfficientNet has been released by Google in 2019, and that is one of the models which is revolutionizing the computer vision space. And this EfficientNet is one of the better performing models these days. And if you take this EfficientNet, you can see the performance of the EfficientNet in comparison with this other processors. It is like quite, this is a red line. So it performs really well, and it's a family of models. You have EfficientNet B0 to B7, and B0 being the smallest variant and B0 7 being the biggest variant. And one of the advantages of using efficient net, so a little bit about the architecture is most of the predecessors of efficient net dealt with scaling at one of the dimensions. Either they were scaling up width, or they were scaling up depth, or they were scaling up the resolution. But efficient net is one of the architectures which did the scaling up uniformly using a compound coefficient. So this is one of the advantages of efficient net. And efficient net is um, efficient net is first of uh, So I'm going to use this transfer learning technique to use this efficient net. I'm using the efficient net B6 here, and then I'm building up all the other layers using transfer learning technique, where I'm just because this is this class binary classification problem. So I'm building up few layers, and the last layer is a sigmoid activation function, and then I'm compiling the model. So the loss is something which they have already given. They have given you, you should use, they've not given you loss function, they've given you the accuracy metric. So it is going to be area under the curve. And the loss, I'm just using binary cross entropy because it's just binary classification problem, and I'm just using a standard optimizer atom, and the metrics is accuracy. And I'm training my model, and it is giving me, this code is adapted for Kaggle submission. So I'm just training my model, and making a prediction on the test data set, saving the CSV file, and submitting it on Kaggle. So this is a very baseline introduction to how to solve this problem using efficient net and TensorFlow 2.0. But there's a lot about this competition which you can dig on your own and learn it. So if you go to the competition page, you have code where there are a lot of codes, like around 100 codes, maybe like 200, 300 people might have written several notebooks. So you can go through these notebooks and you can improve your knowledge further. And there is also discussion forums where you can find the winners list. So if you go to this discussion forum and put search by recently posted, you will be able to find the top winners, like 27th, second place, and then the first place solution, second place solution, and all this. You will have the winner's solution. So what I've given you is, I've just given you a baseline architecture, how to approach the problem, how to use TensorFlow's APIs and all that. With this knowledge, I would highly recommend going through this competition really well, and checking out the discussion forums and the other contributors of this Kaggle notebook section, where you can find a lot more people who would have implemented several research papers and all. So go through that, which will improve your knowledge, and also check out the winning solutions. And this is it from my end. I'm like opening up for questions. If you have questions, then please do ask.
So are you also going to show a walkthrough of your code, or are we going to wind up this?
Yeah, we are going to wind up. This is my code. I have the same notebook in Kaggle. I've
Okay.
just made it private in Kaggle. So yeah, you can also follow me on Kaggle here. This is my profile, and you can also follow me on Kaggle. And we have reached the end of the session. Yeah.
Okay, that was quick. And people, guys, you have any questions? You just ping in the chat box in case you have any relevant questions with respect to CNN or image classification or any kind of these kind of ResNet, efficient net, any kind of questions. And anything in mind? Many of the people who are actually watching this, they might not have the hands-on experience on the image classification or deep learning techniques, which is still okay. But in case people who have already are kind of widgets, or in kind of they already know deep learning, probably you can ask questions if you have anything in mind. Yeah, there is a question, Usha. Uh, how to identify the optimizer that have to be used in a classification problem?
Okay. See, identifying an optimizer is just trial and error. There is like no standard rule that this is the optimizer which will work for you. So there were a lot of research papers which got released from ICLR, computer vision, NeurIPS, of several optimizers which are performing good. And there was a Kaggle who took that research paper and he implemented that optimizer and he released the code in Kaggle, and immediately a lot of people tried and saw whether the performance was increasing, the performance was not improving. And so it's just a trial and error. So stand the lot of most of the Kaggle competitions I've seen, people have used Atom, and people have used RMS prop, and these were the standard optimizers which I've seen people using it. And so it's just trial and error. You might have to experiment with the optimizers.
Any other questions, guys? Okay, I think we'll probably wait for 2 more minutes in case you have any questions, guys. Just ask. In case people who are complete beginners, they can also watch out my CNN. Okay, somebody has a question. Can you share some particular methods that we can try to deal with imbalance and improve AUC scores? So,
Uh, So
yeah,
dealing with the imbalanced data set, I think data augmentation is a very good technique for dealing with imbalanced data set. And so where you can increase the, if it's going to be an image data set, then you can try out data augmentation techniques for improving your uh, you know uh, what to say data set. And the other techniques is these days people also use GANs, and there are also other techniques where they use GANs to generate fake data and all that. There was a use case which in real time use case where we had to, it was a banking scenario and it was an imbalanced data set, and the data collection was very tricky for us. And because it is a banking use case, so it is a personal banking use case and you will have to go live, and if it's going to be if the model is making mistakes, then it's huge. And so there, since the data collection was very very tricky for us, we had employed GANs to generate fake data and all that. So there are several techniques. It depends on use case to use case. Generally, if you have lesser data in, then data augmentation is the most commonly used technique. Other use cases, you will have to analyze it case by case and look out for the recent strategies. If similar use case as anybody else, use some technique and then try to solve it.
yeah, yeah. When it comes to image, yeah, augmentation is one of the techniques you can do, Bharat. Apart from that, it depends upon your use cases. If your use case is somewhere related to speech data, then you can perform some techniques like pitch upshifting, downshifting, increasing volume, decreasing volume. So it depends upon your use case. Which source is best for deep learning to understand easily? Okay.
Yeah, I think Satyajit himself is having a good tutorials, and he's having some being data community and stuff. So I think you should check out with him for the resources, and his check out his resources, and also I think he will be the right person to answer this question.
Yeah, I mean, in case you are a complete beginner in deep learning, you can probably go ahead and check my playlist. But yeah, in case you are looking out for some advanced techniques very specific to computer vision, I don't have that right now. But yeah, I'm planning to do that. People, okay, somebody, okay, Akshay has a good question that for medical purpose, efficient net is purposely useful. It won't be biased. Kindly tell a bit more about efficient net. Uh,
See, if you take the recent Kaggle competition, uh, most of the winning solutions as efficient net. Any image detection, even object detection problems, they use a two class classifier where, one of the two stage, where one of the stages they use efficient net and the other they use YOLO v5 and all that. So computer vision, efficient net, rest net, is ruling that space which is very visible, because any of the Kaggle competitions which is coming out, the winning solution has some part of efficient net. And it just works well with the healthcare data set, because I'll take you and I'll show you. See if you take the compete, and instead of me just saying it is ruling, I'll just take and I'll show you. Uh, so this is the competition space. Here you'll find all the completed competitions. So for melanoma, we have already seen EfficientNet was the winning solution, one of the winning solutions, and you can take maybe NFL. So this one had again EfficientNet and RestNet, a bit of it, and the other competitions you can take fibrosis, Cornell is audio, and global weed detection again is trends neuroimaging. There are a lot of competition. I think this one you can just check out the winning solution. So the first place solution is it? What about the second place solution? Third. This is a sports use case, NFL, but I was also like participating in it. We did not use EfficientNet, but somebody in the top 10 had used EfficientNet. I'm not sure who in the top 10 has used EfficientNet. But yeah, more even object detections, when they use two stages, they use for classification. He has used which architecture? Um, Yeah, he has used EfficientNet. I use the ensemble of EfficientNet B0 to B3. I think so. The winning, so he's the first place solution in that. So this is an object detection problem. Even here, one stage people have used YOLO, and then they've used finally EfficientNet combination. You can go and check any of this architecture. I think people have used EfficientNet extensively in all the winning solutions. So it's a one thing which is doing really good for healthcare problems. And that being said, one more thing which I would like to highlight is Kaggle has got as much as got Kaggle also has got huge shakeup. I think shakeup is very predominant with Kaggle. So if you take this melanoma competition itself, and let me just take this melanoma competition. So
Usha, you
the
there? Not
first
really.
prize winner
We,
was 888 place.
Usha, we are
And
missing out you.
because of the shake-up, he came to the first place.
Usha, we missed out your last three, four
Sometimes
sentences.
there's overfitting happens, and sometimes the So yeah, I've shared the EfficientNet paper, which if you want to read more, you can actually choose this paper. And this is a melanoma competition, which I wanted to show you. EfficientNet works really well for healthcare space. And if you want to read more about it, please go through this paper. And there's also a blog from Google AI. Mm, So this is a blog from, I'm sorry, this is a blog from Google itself on EfficientNet. So you can check this out, and it will give you more in-depth knowledge on EfficientNet. And EfficientNet is very good for healthcare use cases. Of course, the overfitting and all depends on if you are using too many ensembling techniques, improper ensembling, and overfitting it too much. Then obviously it will not give you good results. But there are a lot of other parameters which plays into role, to give the best winning solution. So yeah, are there any other questions?
Yes, Usha, there are some questions. One of the questions, let me just scroll through. Okay, Akshay's questions are somehow answered. Uh, Swaminathan has asked, is maths behind deep learning important or just training is mostly based on intuition? Would you like to answer this, Usha?
So, maths behind deep learning is very important if you want to get into research and all those things. And there are a lot of times when you have to write your own code. So, for the winning solution, see, I'm only talking here. This is the Kaggle use case, so I'm talking with respect to Kaggle and real time use case also to an extent. See, for a real solving a real time use case, you might be using a lot of research papers which has come in 2020, 21 from all the top conferences. You might try to implement few of the research paper and use it in your ensembling. And so that time, if you want to implement a research paper, you might have to understand the mathematics behind it. You will have to understand a lot of mathematics because you have to go through the research paper, understand it and all. So definitely, if you're into competitive data science and out there in real world solving problems, you need to understand. Or if you're doing some tummy toy projects or something like that, which is only you just were getting hands on exercise and stuff, then that time it's not required. But if you're solving real world for a client or for your competitive data science and all, you'll have to understand the mathematics behind it, the deep learning. Only then you'll understand a lot of research papers which you can implement and improve your winning score.
Okay. One more question by Ambarish is that in the submitted solution for the melanoma, do you have the architecture which you used? If you have, can you share with the people who have joined?
So my team solution is something an ensemble of several public models. I think we selected one of my teammates' solution. We used Efficient Net only, and I'll share that exact notebook which we used with Satyajit. He might be able to share it in the WhatsApp group. It's my teammates' notebook. I'll just have to scroll and find that notebook for you. I'll just share it with Satyajit. He'll be
Sure.
able to share it with all of you.
Yeah, sure. I'll make it. I'll make it a part of the description once I get this from Usha.
Yeah.
One more question is, can we make our own net instead of using efficient net to avoid 1% of biased nature? Because nowadays new diseases are emerging which world might not be having pre-images like the COVID-19 virus.
You are free to create your own architectures. You can create your own architectures, but you also require, if you want to create something as powerful as efficient net, then you require that kind of an infrastructure. These kind of huge models requires as millions of parameters to train huge models like efficient net. You require that kind of an compute storage and GPUs and that kind of an intense compute strategies and all that in place. So you are free. You have all the rights to create your own architecture. Nobody is going to stop you, but provided you have that kind of an compute GPU to train huge architectures. Yeah. This is my thing, See, how are other people? We had EfficientNet now there's EfficientNet version 2 which has come out. There are a lot of people coming, NF nets which has come out with DeepMind release NF nets. So, there are new people, new researchers coming up with new architecture. So you just like how they are doing, have all the rights in the world to create your own architecture, provided somebody sponsors you with GPU and the other compute resource which you require.
Okay. One question is from Tushar, which I already told that it's little bit lengthy to answer. We can connect on LinkedIn and answer. So his question was, as a data scientist, which type of work we do on a daily basis. So Tushar, it's going to be very difficult for us to explain right now. Maybe we can connect on LinkedIn and I'll try to help you out. One question from Castra is, what kind of GPU is used for efficient net?
So I think for training efficient, I think Google would have used TPUs, because Google, it is the model coming from Google. So the entire DeepMind and all Alphabet group of companies, they use TPU as a runtime accelerator, which is much more faster than GPUs. So I think Google might have used this higher probability. Google would have used TPUs for training the efficient net. And if you are going to use EfficientNet, all you have to do is pip install EfficientNet. You saw in the collab notebook which I did, and you can start using the pre-trained model. So
Yeah.
for doing this, you don't require my much degree. You can just use collab GPU. That's more than enough. Yeah.
Okay, probably you must answer Tushar's question as well because he also pinged me again that what a data scientist has to do with respect to deep learning in the real world. Can you just give an example so that he's kind of you
See,
know
the real world, the problem statement could be anything. So, real world, you're having a retail showroom. So, there is a lot of videos which is being captured, and you want to detect the, retail objects. Could be shampoo and all this. This is an object detection problem. So, the other Swiggy recently during coronavirus term, they released an, the Swiggy employees. They have to, they prepared the mask detection, whether the Swiggy employees themselves are wearing the mask and whether the customer is wearing the mask detection problem. They released a particular, their app also had the mask detection, feature installed within. And there could be anything like object detection is very useful in this coronavirus time, because especially it was used for the face mask detection. I'm just telling these examples. You might think, who's going face mask detection is all over the LinkedIn, who's going to use, but that's a real world use case. A lot of companies were using it. And there were a lot of apps which were coming out for physical distancing and all that. So these are very important for somebody like Ola, or somebody like Swiggy, and somebody like Uber, and all these companies, telecommunication companies, because for them the social distancing and all this matters a lot, and mask detection is also matters a lot. So this is all computer vision problem statements only. And you want to you have a heavy manufacturing plant unit, and you have a video which keeps monitoring all the performances every second, and you want to detect any anomalies using the videos. So detect the leakage of oil, detect something wrong in the plant. That also can be done using video analysis and all. So there's a lot of use cases out there. So depending on the domain and depending on what you which project you are in, it depends. Like, you if you're a consultant, you could work in a wide variety of projects. There's no restriction. Yeah, this is the answer.
yeah, as already explained by Usha that you know concepts remain the same, but you have to utilize your concepts with respect to your domain. So, for example, you're working in healthcare, there could be tons of use cases in that area. So that is it. So it's up to your domain. So once you know the concepts of deep learning, machine learning, computer vision, and all those things, next thing what you need to do is just go to the Google and just try to do a basic research on what could be the probable use cases in your domains. uh yeah, Swaminathan, you had asked that is it possible to use sections of two or more pre-trained model to improve predictions? Yes, it is possible. Any other questions? There's a lot of questions, so it's really good that people are interacting. Uh, Tushar, I think so. Tushar is again asking about some use cases with respect to medicine and hospital or healthcare domain. I mean, there are multiple use cases, Tushar. I think my suggestion to you would be to go ahead and go do a Google research. You will find tons of blogs in that. There are multiple use cases in medical industry as well, right? When it comes to imaging and lot of diagnostics and all those things are also there. Any other questions? Medical imaging, diagnostics, and all those things. Guys, do we have any questions or probably 2 more minutes? And if we don't receive any question, then we'll wind up the session. Okay. Anyways, you already have Usha's and mine LinkedIn channel, LinkedIn link as well in the description below. So in case your questions are unanswered, or if you have any questions, you can ping us on LinkedIn and ask. So thanks for joining me for the session, Usha. The
Yeah,
code
thank you so
walkthrough.
much, Satyajit. It's been my pleasure addressing the Being Data community. And I'm wishing you all the very best for Being Data to grow into one of the biggest communities in the world.
Thank
Yeah.
you, thank you, thank you for your kind words. Your code walkthrough was really nice, and of course, we will send the detailed notebooks to all the students who have joined the session. So you
Yeah.
will definitely have an hands-on on that part. And yeah, as Usha already told you, you whenever you are working on some Kaggle project or something, you do have a lot of submissions by other fellow members, right? So that's a very good area where you can explore and you can dig in and learn how people have implemented the models. Okay, so I know for some of you the session might be a little bit difficult to grasp, but yeah, it will be consumed later once you are good with the basics. Thank you all for joining the session. I also have few sessions lined up on various topics. Not few. I have planned to do online webinars almost every week. So next weekend I'm planning to do a end-to-end chatbot implementation using Rasa. So please subscribe to my channel to keep me motivated, share my videos as much as possible, and yes, do like the videos as well. Thank you guys. Thanks for joining. Good night. Thank you,
Yeah.
Usha.
Thank
Thank
you
you.
so
Thanks
much.
for
Yeah.
joining. It
Thanks.
was a pleasure
Yeah.
having you.
Yeah. Thank you. Bye bye. Yeah.
Okay. Thank you guys. Bye bye.
Bye.